Hello kids, in this video we are looking at sheet 2 of the homework of the chapter numbered system. So there are 10 sums which we are supposed to do. I'll take each sums one by one. The first sum was a prove that sum. The LHS of the sum is x raised to a by x raised to b whole raised to a plus b minus c into x raised to b by x raised to c whole raised to b plus c minus a into x raised to c by x raised to a whole raised to c plus a minus b. We have to show that this is equal to 1. Step 1, what we can do is we can open the bracket. So a will get multiplied with this 3 term, b will get multiplied with this 3 term. Same we will do for this remaining 2 terms. So if you open the bracket, this will be a into a square, a into b, ab, a into minus c, minus ac. Same with the denominator, you are going to multiply b to this 3 terms, so it will become ab plus b square minus dc. We'll do the same here, you multiply b with this 3 terms, so it will be b square plus bc minus ab. In the denominator, on multiplying c to this 3 term, you get bc plus c square minus ac. Perform the same step here, you multiply c to the 3 terms, it is c square plus ac minus bc. In the denominator, multiply a, you get ac plus a square minus ab. Now you have 3 terms, all the 3 terms are in multiplication relation and they all have bases as x. So in multiplication you add the power, so for the numerator we have 3 terms with bases as x, we will add their power, so we have x raised to a square plus ab minus ac plus b square plus bc minus ab plus c square plus ac minus bc. Applying the same concept in the denominator, you have 3 terms with the same power x. The 3 terms are in multiplication relation. You add the power, you have x raised to ab plus b square minus bc plus bc plus c square minus ac plus ac plus a square minus ab. Now plus ab minus ab gets cancelled, minus ac plus bc minus bc. Same in the denominator, plus ab minus ab plus ac minus ac plus bc minus bc. So now what we have in the numerator is x raised to a square plus b square plus c square. Same way in the denominator we have a square plus b square plus c square. So what do we notice? We notice that we have the same term in the numerator and denominator, it gets cancelled. This will be equal to 1. This is your RHS. So this is the first sum of the homework sheet. I'll erase this. Moving on to the second sum. In the second sum it is, they have given that the value of a raised to x is b, the value of b raised to y is c, and the value of c raised to z equals to a. They have asked us to prove that the product of x, y and z is 1. Yes. how we'll proceed is, they have given that a raised to x is b. If this exponent x shift to the other side, you will get a as b raised to 1 by x. That is, x in the power goes to the other side, it becomes 1 by x. So you have the value of a in terms of b. Now similarly, let's get the value of c in terms of a. So you have c raised to z. Let me give this relation as 1 equals to a. If z goes to the other side, it will become 1 by z. So what is z? C equals to a raised to 1 by z. But you already know what is the value of a. A is b raised to 1 by x. So from equation 1, you can replace this a by b raised to 1 by x. So it is b raised to 1 by x, and you already have 1 by z. 1 by x into 1 by z is 1 by xz. So you have the value of both a in terms of b and c also in terms of b. Now, this third, one more relation that they have given that b raised to y is c. But we know what is the value of c. C is b raised to 1 by xz. So we replace c by b raised to 1 by xz. Now here you have LHS and RHS same, and you notice that the bases are also same. If the terms are same and they have the same base, then their exponents also have to be same. So you can say that y equals to 1 by xz. If xz comes to this side, here it is in the denominator, it comes on this side, it will be in the numerator. Numerator, you already have y, xz gets multiplied to y, so you will have x, y, z equals to 1. So the sum gets proved there. That was the second sum. Now, moving on to the third sum. In the third sum, they have given that a raised to x equals to b raised to y equals to c raised to z. They have asked us to prove that, and they have also given one more relation. They have given that b square equals to ac. They have asked us to prove that y equals to 2xz upon x plus z. Now, we know that a raised to x equals to b raised to y equals to c raised to z. They all three have the equal value. Let's say their value is equal to k. Now from this relation, you have a raised to x equals to k. So what will be a? A will be, x goes to the other side, it will become 1 by x. Similarly, b raised to y equals to k. Y goes to the other side, the value of b will be k raised to 1 by y. Similarly, c raised to z is also equals to k. Therefore, value of c will be z goes to the other side, it will become 1 by z. So now we have value of a, b and c. They have given us a relation between a, b and c. They have given that b square equals to ac. This is given. What is b? B is k raised to 1 by y. So we replace b by k raised to 1 by y. This is b square, so it will be k raised to 1 by y whole square. What is a? The value of a is k raised to 1 by x, and c is k raised to 1 by z. So how are these two? These two are in multiplication relation. Same base is k. So you will add the power. So now this is, what is 1 by y into 2? It is 2 by y. And what is this? You add the power, it is 1 by x plus 1 by z. What do you notice? You notice that they have the same base. They have the same base, you can equate the power. So 2 by y equals to 1 by x plus 1 by z. What is the LCM of x and z? The LCM of x and z is xz, right? It is xz. So you have x, so what will come to the numerator? Z. You have z, what will come to the numerator? It will be x. Now take this xz on this side. It is on this side it is in the denominator. If it comes to the other side, it will come to the numerator. And shift this z plus x on this side. Here it is in the numerator. When it comes on this side, it will be in the denominator. I write z plus x as x plus z. One and the same thing. Shift the y on the other side. Here y is in the denominator. If it comes to the other side, it will be in the numerator. So you got the value of y as 2xz upon x plus z. That was the third sum. Fourth sum. Fourth is an easy question. They have given that 5 raised to x minus 3 into 3 raised to 2x minus 8 equals to 225. So if 225 can be expressed as the product of 5 raised to some number and 3 raised to some number, we have to find the value of x. Now let's do the prime factorization of 225. Now we can factorize 225 as 5 into 45 is 225, 5 into 9 is 245, 3 into 3 is 9 and 3 into 1. So the prime factorization of 225 as 5 and 3 as the prime factor. You have 5 twice and you have 3 twice. So we can write 225 as 5 square into 3 square. So let's write that. Over here you have, on the LHS we have 5 raised to x minus 3 into 3 raised to 2x minus 8. Now we express 225 as 5 square into 3 square. Now when you compare the terms with the same base, we can say that therefore 5 raised to x minus 3 equals to 5 square and 3 raised to 2x minus 8 equals to 3 square. Here both the terms have the same base, so we can equate the power. Therefore x minus 3 equals to minus 3 goes there, plus 2, 2 plus 3 is 5. So value of x is 5. Similarly, the base are same, you can equate the power. Therefore you get 2x minus 8 is 2. Minus 8 goes to the other side, plus 8, 2 plus 8 is 10. So value of x is 5. So either way you get x as 5. So that is the solution. The value of x would be 5. That was question number 4. Let's take the fifth sum. Similar question. In the fifth question we have 9 raised to x plus 2 equals to 720 plus 9 raised to x. Then we have to find the value of 4x raised to 1 by x, right? This is the value that we need to find. So first we would solve this and get the value of x. So 9 raised to x plus 2 can be broken down into 9 raised to x into 9 square. Yes, x plus 2 can be written as to the power x and to the power 2. Because if they are in multiplication relation, you add the power. So this into this is nothing but 9 raised to x plus 2. So I wrote 9 raised to x plus 2 as 9 raised to x into 9 square. This is 720 and this is 9 raised to x. Now what is 9 square? 9 square is 81. So now what do you have? You have 81 times 9 raised to x. What is this? 1 time 9 raised to x. Bring that on this side. Over here it is positive. If you bring it on the other side, the sign will change. So it is minus 9 raised to x, and over here you will have only 720. So what is this? It is 81 times 9 raised to x minus 1 times 9 raised to x. So 81 times 9 raised to x minus 1 times 9 raised to x is nothing but 80 times 9 raised to x. 0 on either side gets cancelled. 8 ones are, 8 nines are. So now we have 9 raised to x equals to 9. Can I write 9 as 9 raised to 1? Yes. The base is same. Both sides 9 is the base. So you can equate the power. So you have x equals to 1. Once you have the value of x, we got to find the value of this term. We know x is 1. So we replace x by 1. 4 into 1 is 1. 4, sorry. And 1 by 1 is 1. So 4 is to 1 is 4. That will be the answer for the fifth sum. Let's move on to question number 6. Question 6. The first sum of question 6, it says 2 raised to 2x plus 1 is equal to 17 times 2 raised to x minus 2 cube. We have to solve it, that is, we have to find the value of x. Now 2 raised to 2x plus 1 can be broken down as 2 raised to 2x into 2 raised to 1. Now this is 17 times 2 raised to x, 2 cube can be written as 8. Now 2 raised to 1 is nothing but 2. 2 raised to 2x, can I write 2 raised to 2x as 2 raised to x raised to 2? Yes, because x into 2 is nothing but 2x, so I wrote 2 raised to x. 2x as 2 raised to x raised to 2. 2 raised to 1 is 2. Now this is 17 times 2 raised to x minus 8. If you notice both sides we have 2 raised to x as a common factor. Just to make the question look easy, I am making an assumption. I write let 2 raised to x equals to m. We will replace 2 raised to x as m, so this equation will become 2, this is m and this is squared. 17, 2 raised to x is m minus 8. Plus 17m comes on this side, it is minus 17m, minus 8 comes on this side, it is plus 8. So on the RHS now what you will have is 0. So what is this? It is quadratic trinomial. If you have quadratic trinomial, we will factorize it using splitting middle term. We are very familiar with splitting middle term, and splitting middle term first step that we do is we multiply the coefficient of m square and the constant term. So over here you have 2, over here you have 8, 2 8s are 16. Then you look at the sign. If you have a positive sign, you have to think of two numbers which on multiplication gives 16 and on addition gives 17. Two numbers which on multiplication give 16 and on addition give 17. The numbers are 16 and 1. 16 ones are 16 and 16 plus 1 is 17. So you got the two numbers 16 and 1. When you have a positive sign here, always remember both the numbers will have same sign. So 16 and 1, either both will be positive or both will be negative. Now because there is a minus sign here, both the numbers would be negative. So you write this as 2m square, your two numbers are 16 and 1. This is minus 16m and this is minus m. Now what is common in the first two terms? 2m is common. So after taking common, what remains here? M. Minus, if you took 2 common, what remains in 16? 8. Then you have minus sign, write that sign. What is common in m and 8? 1 is common. Because you have taken minus sign outside, the sign changes. Plus 8 will become minus 8. Now you notice m minus 8 is common. When you take m minus 8 common, what remains is 2m minus 1. Now what do we have? We have this into this is 0. Now the product of these two factors is 0. If the product of the two factors are 0, we get to know that one factor is compulsorily 0. It means either m minus 8 is 0 or 2m minus 1 is 0. If m minus 8 is 0, m should be 8 because 8 minus 8 is 0. So you got m as 8. And if 2m minus 1 is 0, the value of m will be, because here there was minus 8, we got plus 8. Now minus 1, you will write plus 1. And 2 is multiplication, so you will divide 2. So you got the value of m as 8 or m as 1 by 2. But what is m? M is 2 raised to x. So now we can say therefore 2 raised to x is 8 or 2 raised to x is 1 by 2. Now what is 8? 8 is 2 cube. And here can I write 2 raised to as 1 by 2 as 2 is 2 raised to 1? Can I write it as 2 raised to minus 1? Yes. Now if 2 raised to x is 2 cube, base are same, you will equate the power, so you get x is equal to 3. Or base are same, you can equate the power, x equals to minus 1. So that was the first sum of question 6. Let's do the second sum. In the second sum of question 6, the question is 5 raised to 2x plus 1 is equal to 6 times 5 raised to x minus 1. Similar question. First step, we will split 5 raised to 2x plus 1 into 5 raised to 2x into 5 raised to 1. This is 6 times 5 raised to x minus 1. 5 raised to 1 is 5, and we will write 5 raised to 2x as 5 raised to x raised to 2 equals to 6 times 5 raised to x. What do we notice? We notice the term 5 raised to x in both sides. We are going to assume 5 raised to x as m. So now we will say let 5 raised to x equals to m. Therefore you write this as m, so this becomes m square. 5m square. This is 6, 5 raised to x is m minus 1. Plus 6m comes on this side, it will be minus 6m, and minus 1 comes on this side, it will be plus. Now what do we have? We again have a quadratic trinomial. So we will be doing splitting the middle term. Step 1, multiply a and c, that is coefficient of the square term and the constant term. 5 into 1, 5. Now because we have a plus sign, two numbers on multiplication should give 5 and on addition should give 6. The two numbers are 5 ones are 5 plus 1, 6. So you got the two numbers are 5 and 1. If you have a positive sign here, both the numbers will have same sign. Now because we have a minus sign here, both numbers will be negative. That is 5 will also be negative and 6 will also be, 1 will also be negative. So you write this as 5m square minus 5m minus 1m plus 1. What is common in the first two terms? 5m is common. If you took 5m common, what remains? M. Minus sign. If you took 5m common, what remains? 1. You have minus sign, write minus sign. What is common in m and 1? 1 is common. Because you have minus sign outside, sign changes, plus 1 will become minus 1. You notice m minus 1 is common. You take m minus 1, what remains is 5m minus 1. What do we have? We have this into this is 0. If you have the product of two terms 0, one term has to be 0. So either m minus 1 is 0 or 5m minus 1 is 0. If m minus 1 is 0, m would be plus 1. And if 5m minus 1 is 0, m would be 1 by 5. Now what is m? M is 5 raised to x. Therefore 5 raised to x is 1, or 5 raised to x is 1 by 5. Can I say 1 is nothing but 5 raised to 0? I want the same base 5, so I expressed 1 as 5 raised to 0. Same way, can I say 1 by 5 is nothing but 5 raised to minus 1? The base is same, you can equate the power, therefore x is 0 or x is minus 1. Moving on to the next sum, question number 7. Question 7 again has two sums. The first question, how does it read? We read it as cube root of 6 square and they have asked us to make its order 6. Order. Right now, because it's a cube root, the order is 3. Now you want to make the order 6. That is, you don't want cube root, you want 6th root. First important thing to understand, what is this? This is square root of x. Square root of x can be expressed as x raised to 1 by 2. What is this? Cube root of x. You can write cube root of x as x raised to 1 by 3. What is this? Fourth root of x. Fourth root of x can be written as x raised to 1 by 4. Once this is clear, we can proceed with the solution. So you have cube root of 6 square. Cube root of 6 square can be, because it's cube root, it will be 1 by 3. So it is 2. You already had a square, so it becomes 2 by 3. Now you want to make the order 6. That is, you don't want cube root, you want 6th root. So here you don't want 3, you want 6. What will you multiply with 3 to make it 6? You will multiply 2. But if you are multiplying 2 to the denominator, you have to multiply 2 to the numerator. So this will become, we are multiplying 2 to the numerator and denominator. So this is 6 raised to 4 by 6. Now you have 6 in the denominator. So I could write it, because as I have 6 in the denominator, I could write it as a 6th root. 6th root of 6 raised to 4. That was the first sum, where we converted a third order question to a 6th order question. Now let's take the second part of question 7. In second part of question 7, they have given cube root of 6 and we want to make its order 15. The order is 3 right now, we want to make it 15. First, you will replace this root sign by exponent. Because it is cube root, you can write it as 1 by 3, but you want 15. What will you multiply with 3 to make it 15? 5. So you multiply 5 to the numerator and denominator. So this becomes 6 to the power 5 by 15. Now because I have 15 in the denominator in the exponent, it is a 15 order. And now this will be 6 raised to 5. Yes, so that was question number 7. Let's take question 8. We have to express the following as pure surds and mixed surd. We will also simultaneously understand what do we mean by pure surd and mixed surd. When we look at the first question of question 8, it is 3 by 4 times cube root of 128. Now this is a mixed surd. Why? 3 by 4 is a rational term and this is an irrational term. This is your surd. If a term has both rational as an irrational, then it is a mixed surd. Now, because as it is mixed surd, we are going to convert it into a pure surd. That is, we don't want this rational term. So, what is the concept here? What is root of 4? Root of 4 is 2. If I want to write 2 in irrational term, I will write 2 as root 4. So, what I did is, I can write 2 as root 4. What is the square of 2? 4. So you write the square root sign and do the square of 2. Similarly, if you have 3 and you want, it's a rational term, if you want to write it in surd, the square of 3 is 9. So you can write 3 as root 9. Yes, because root of 9 is nothing but 3. Using the same concept, we have a cube root sign here. So now you want to take this 3 into the cube root. Here we took this 2 to the square root, so we squared the number. 3 to the square root, we squared the number. Now you want to insert this 3 in the cube root term. So what is the cube of 3? 27. So you can write 3 as 27. Now what is the cube root of 27? 3. So you would get 3. Same way if you want to take this 4 in the cube root. What is the cube of 4? 64. So both 3 and 4 goes into the cube root term. It becomes 3 becomes 27 and 4 becomes 64. How did we get? Because it was cube root, we did the cube of 3. The cube of 3 is 27 and the cube of 4 is 64. We already have a term in the cube root. What is that? 128. 64 ones are 64 twos are. What is 27 into 2? 54. So your answer is cube root of 54. Do we have any rational factor? We do not have a rational factor. So now it is a pure surd. Let's look at the second question of question number 8. In the second question, if you notice, it's a pure surd. They have given fifth root of 96. Now we want to convert this into mixed surd. That is, a mixed surd, it should have a rational factor. Now this is fifth root. We know 96 is 32 into 3. Why I am expressing 96 as 32 into 3? Because I know 32 is 2 to the power 5. Now this was fifth root. I am writing 32 as 2 raised to 5. Now what is the fifth root of 2 raised to 5? Like the square root of 2 square is 2. The cube root of 2 cube is 2. The fourth root of 16 is 2 raised to 4. The fourth root of 2 raised to 4 will be 4. Same way the fifth root of 2 raised to 5 would be 2. So 2 comes outside the fifth root. What do you have in the fifth roots? You have 3 remaining. So now it has a rational factor as well as an irrational factor. So it is an example of mixed surd. So we have converted a pure surd question into a mixed surd. That was question number 8. Let's look at question number 9. Question 9, such questions are important from examination point of view. We have to simplify. What is the question? It is 15 times square root of 16 minus square root of 216 plus square root of 96. We know 16 is 4 square. Same way 216. 16 is a perfect square term. 216 is not a perfect square term. The biggest perfect square factor of 216, if you want to find the perfect square factor of any term, what you do? You factorize that term. So this is 108, 2, 54, 2, 27, 3, 9, 3, 3, 3, 1. So now if you try to pair it, you have a pair of 2, a pair of 3. The other two terms cannot be formed in pair. So now you have 2 and 3. So 2 3s are 6. So can I write 2 square and 3 square as 6 square? Now what do you have remaining? 2 into 3 is 6. So we can express 216 as 6 square into 6. If you do the same for 96, 96 could be expressed as 16 into 6. 16 is 4 square into 6. That is, the biggest perfect square factor of 216 is 36 and the biggest perfect square factor of 96 is 4 square, that is 16. Now what is the square root of 4 square? Square root of 4 square would be 4. What is the square root of 6 square? The square root of 6 square would be 6, so you have 6 in the root. What is the square root of 4 square? The square root of 4 square would be 4, so you have 6 remaining in the root. So now 15 fours is 60. This is minus 6 times root 6 plus 4 times root 6. They are like terms. So you add or subtract the coefficient. Minus 6 plus 4 is minus 2. This is your answer of simplification question 1. Let's look at the second sum of question number 9. The second sum is 5 times cube root of 250 plus 7 times cube root of 16 minus 14 times cube root of 54. In the previous sum there was square root. As in the previous sum there was square root, we found the biggest perfect square factor. Here if you notice we have cube root, so we are going to find the biggest perfect cube factor. Now the biggest perfect cube factor of 250 is 125. 125 is 5 cube and 250 is 125 into 2. Same way the biggest perfect cube factor of 16 is 8. 8 2s is 16. We can write 8 as 2 cube. The biggest perfect square factor of 54, perfect cube factor of 54 is 27. 27 into 2 is 54. We will express 27 as 3 cube into 2. Why are we expressing it in cube? Because we have cube root. Now what is the cube root of 5? 5 cube. The cube root of 5 cube would be 5. What remains inside the cube root? 2. What is the cube root of 2 cube? It will be 2. What remains inside the cube? This 2. What is the cube root of 3 cube? It will be 3. What remains inside the cube? This 2. So now 5 5s are 25 times cube root of 2. 7 2s are 14 times cube root of 2. 14 3s are 42 times cube root of 2. Now we notice all the three irrational terms are like terms because they have the same irrational term cube root of 2. So we can add or subtract the coefficient. Over here we have 25 times cube root of 2, 14 times cube root of 2 and 42 times cube root of 2. When we add their coefficient, 25 plus 14, 39. 39 minus 42 is minus 3. Your answer is minus 3 times cube root of 2. That was the second sum of question number 9. Let's look at the third question of question number 9. The third question is 4 times square root of 3 plus 3 times square root of 48 minus 5 by 2 times square root of 1 by 3. Now here we have square root, so we will just check if they have a perfect square factor. Now 3 does not have any perfect square factor, it by itself is a prime number, so I wrote it as it is. The biggest perfect square factor of 48 is 16. 16 is 4 square, 16 3s is 48. Now this would be, what is the square root of 1? Square root of 1 is 1 and the square root of 3 is root 3. So I can write square root of 1 by 3 as 1 by root 3. So this is 4 times root 3. What is the square root of 4 square? Square root of 4 square would be 4. 4 into 3 is 12. What remains inside the root is 3. 5 ones are 5 and in the denominator 2 root 3. These two are like terms. 4 times root 3 plus 12 times root 3 can be written as 16 times root 3. Now the LCM is, the LCM of 1 and 2 root 3 would be 2 root 3. You'll multiply 2 root 3 to the numerator. What is 16 2s are? 16 2s is 32. And what is root 3 into root 3? Root 3 into root 3 is 3. Yes, we have discussed. Root 2 into root 2 is 2. Root 3 into root 3 will be 3. This is 5. What is 32 into 3? 96 minus 5 by 2 root 3. So this is 91 by 2 root 3. This is your answer. But always prefer to keep your denominator rational. Now 2 root 3 is irrational. What is the smallest rationalizing factor of 2 root 3? It will be root 3. So what will you multiply to rationalize? You will multiply numerator and denominator by root 3. Yes, we all are familiar with rationalizing denominator. 91 into root 3 is 91 root 3. In the denominator, what is root 3 into root 3? 3, and 3 into 2 is 6. So this is your answer. Now let's look at question number 10. Question 10 has two questions in it. They have given us an irrational term in the first term. The two terms are cube root of 6 and fifth root of 8. They have asked which is greater. Yes. So what we are going to do? We are going to make the order same. This is third order and this is fifth order. Now we will make a similar order. Now 3 and 5, what is the LCM of 3 and 5? 15. So we are going to make this also 15 of order 15 and this term also of order 15. We have already seen how to change the order. Now cube root of 6 can be written as 6 raised to 1 by 3. You want to make the order 15. What will you multiply with 3 to make it 15? 5. So you multiply 5 to the numerator and 5 to the denominator. So this is 6 raised to 5 by 15. Yes. Now, so we could write this as 15th root of 6 raised to 5. Now what is 6 raised to 5? 6 raised to 5, you find the value. It will be 7,776. So cube root of 6 is the 15th order of 7,776. Now let's convert this also into a 15 order of order 15. This is fifth root of 8. Fifth root of 8 is nothing but 8 raised to 1 by 5. To make it of order 15, you multiply 5 to 3. So you multiply 3 in the numerator and denominator. So this is 8 raised to 3 by 15. So we can write this as 15th root of 8 cube. Now what is 8 cube? 8 cube is 512. So now this is the 15th root of 7776 and this is the 15th root of 512. We know this will be bigger than this, so we can say since 15th root of 7776 will be greater than 15th root of 512, which is this number actually? It is cube root of 6. And what was this number actually? It is fifth root of 8. Hence we can say this number is greater than this. Now the last question of the sheet. In the last question, we have to again identify which number is greater. The first number is square root of 1 by 2 and the second number is cube root of 1 by 3. So first let's make the order same. Square root of 1 by 2 is nothing but 1 by 2 raised to 1 by 2. And cube root of 1 by 3 is nothing but 1 by 3 raised to 1 by 3. You want to make the order same. This is a second order value and this is third order. The LCM of 2 and 3 is 6. To convert 2 to 6, you will multiply 3. We are multiplying 3 to the numerator and denominator. So this becomes 1 by 2 raised to 3 by 6. 6 can be written as 6th root of 1 by 2 cube. Now the cube of 1 by 2 is 1 by 8. Same way to convert this into a 6 order 6, 3 will be multiplied by 2. So you multiply 2 to the numerator and denominator. So this is 1 by 3 raised to 2 by 6. By 6 is 6th root. So this will be 6th root of 1 by 3 square. Now the square of 1 by 3 is 1 by 9. Now numerator is same. Here the denominator is 8, over here is 9. The smaller the denominator, the greater the value. So we can say 1 by 8 would be greater than 1 by 9. If 1 by 8 is bigger than 1 by 9, then the 6th root of 1 by 8 will be bigger than 6th root of 1 by 9. So you will say, since 6th root of 1 by 8 is greater than 6th root of 1 by 9, therefore what is this number actually? The square root of 1 by 2 is greater than this number is cube root of 1 by 3. So that completes the sheet. Thank you.